Welcome back to Introduction to Statistics. Today we're going to look at basic probability. Probability is nothing more than what's the likelihood that an event will happen. And an event's either going to happen or it's not going to happen, or there's going to be some likelihood in between. So probability is always between 0 and 1. It can be 0 if it's not even possible. It can be 1 if it's always going to be possible. So as you look at the probability of an event, and this is just our notation, the probability of an event is going to be greater than or equal to 1, or 0 rather, and less than or equal to 1. So when the event can't happen, for example, what's the probability of pulling out a blue sock out of a drawer that only has white socks in it? That's going to be 0. And then a probability of pulling out a white sock out of the drawer that only has white socks in it, that's going to be the probability of 1. So, as you can see, it's always going to be between the 0 and 1. And that's important to remember as you work problems. So if you get a probability that's greater than 1, you've done something wrong. Now, probability is determined by the number of outcomes for that event divided by the total outcomes possible. For example, when you roll a die, the odd number with one roll of dice is, I should say die there, obviously. There are 6 outcomes possible, 1, 2, 3, 4, 5, or 6, and 3 of those are odd. So there would be 3 out of the 6, or 1/2. And we'll take a look at some of these in just a little bit. When you look at the red, blue, and green, and we'll look at some of this using a spreadsheet here just shortly. But there's the probability of red. Well, there's 3 out of the 6. Blue, there's 2 out of 6. And green, 1 out of the 6. Sometimes it's helpful, just as a lot of statistics, sometimes it's helpful to have a graph, as long as that graph is an accurate graph, obviously. And so it does kind of help sometimes to make it a little bit more meaningful. I've seen graphs such as these that, they'll be talking about probability, and instead of probability, they'll show a frequency table or some kind of a frequency graph. This is just a bar graph here. But, this obviously could not be a probability graph because you've got a 3 and a 1 and a 2, and that obviously adds up more to 1 than 1. So the probability graph that you see, if you would add up the probabilities, you would see that total is 1. Probably one of the best ways of showing the probability visually is through a pie chart. And again, we will do that in using Excel in just a little bit. In fact, let's see if I can bring up my Excel worksheet here. And I thought I probably could. There we go. As you look at this was that example of the blue, and you see some of my notes over here. But if we looked at the blue, there was 1 chance out of 6, so we said that. If we looked at the red, there were 3 chances out of 6, which would be simplified to 1/2, and the green was 2 out of the 6, or simplified to be 1/3. If you look at this, and I'll bring this over here just a little bit. If you look at this chart here, all I did was divide, 1 divided by 6, 3 divided by 6, and so forth. So then when we would graph this, with a pie chart, you get something that looks like this. And you can, obviously label the charts or whatever. But that is just the basic probability. And again, you'll notice those total up to 1. Now, just like any time when we're rounding, sometimes when you total up a column because of rounding within the problem, that might be slightly under or slightly over, but that was only because of the rounding problems. But let's look at a couple other things with probability. If we go to toss a coin, it could be heads or tails, assuming it's a fair coin. The probability that it's going to be a heads is going to be 1/2. Just a 0.5 for heads. Probability it's going to be a tails when you toss the one coin is a 0.5. Now that is what's called theoretical, because we're just looking at our objects in this case and saying this is what should happen. Now, if you did an experimental, or sometimes called empirical probability, you would be looking at just conducting the experiment. Maybe you flipped the coin 100 times, and what did you get? You may end up with 75% of them being heads, or you may end up with only 25 being heads. But that's the concept behind theoretical and experimental, is that you would have theoretical is what you would expect to happen just based on what you're observing in terms of it should be equally heads or equally tails. That's the same way with the dice as you look at that. Now, if you were going to talk about how would you, if you flip the coin twice, what would be the possibility of getting 2 heads, or a head and a tail, or 2 tails? Well, if you flip the coin the first time, it's 1/2. You flip the coin the second time, it's 1/2. And what you'll do is multiply, and we'll talk about this multiplication rule in just a little bit. But that's going to be actually 1/4 there. It's going to be 1/4 for the tails. And for head tail or tail head, either way, then it would be a 0.5. So one of each would be a 0.5. And that's called a multiplication rule, and we'll talk about that here just shortly. But before we do that, let's look at the dice, because a lot of times we use the dice in talking about basic probability. And if we wanted to just talk about what's the probability of rolling a 2, well, there's only 1 2 out of the 6 possibilities, so that's just 1/6. If you wanted to again talk about what's the probability of say a 1 or a 2, well, now you would have 2/6. Or the probability, and again you could simplify that to 1/3, obviously. What's the probability of an odd number? Well, there are 3 odd numbers out of the 6, so 3/6 or 1/2. Now it gets a little bit more complicated when you start looking at a pair of dice, for example, because when you roll a pair of dice, you could have the numbers 2, 3, 4, 5, whoops, not 55, but 5, 6, 7, 8, 9, 10, 11, or 12. So all those would be possibilities. But it becomes just a little bit more complicated, because you have to look at, how can I get a 2? Well, the only way I can get a 2 is a 1, 1. Whoops. Better get this formatted properly. Sorry about that. Just want this to be text. Okay, here we go. Well, I guess not. 1, 1. It would give you a 2. To get a 3, you could go a 1, 2, or you could go a 2, 1. To get a 4, a 1, 3, whoops, a 2, 2, or a 3, 1. And that continues on. And so you can see that when we have probabilities here, when you get all done, there are 36 different combinations that you will list here. And to get that 2, there's only 1 out of the 36 would be a 2. There'd be 2 out of 36 that would be a 3. There'd be 3 out of 36 that would be a 4. When you get on down here, you will see that there are, well, let's just do that. There's 1, 5, whoops, 1, 5, 1, 6 rather, 1, 6. There's a 2, 5. There's a 3, 4. There's a 4, 3. There's a 5, 2. And there is a 6, 1 as ways of getting a 7. So when you count all that up, which gets a 7, we would have 6 out of 36. 6 out of 36 possibilities. So when you're trying to figure out, what's the odds of getting certain numbers, you'd have to add these up. For example, you might ask somebody, well, what, I want just maybe 4 numbers. If I wanted to pick 4 numbers, I would pick this one and these 2, and then either the 5 or the 9. And this gives you the greater probability. And again, when you add them all up, you would have 36 out of 36. Now, again, there's some games you can play. There's some other things you can do, and we can talk about that in future videos. But let's now look at a couple other terms that you come across, and one is an independent event, another is a dependent event, but both of them are going to use this multiplication rule, which looks just pretty much the same. It's a multiplication. Now, independent means if you're talking about 2 events and they are independent of each other. So what happens on the first has no bearing on what happens on the second. If they're dependent, what happens on the first does make a difference. And this is how you see the notation. Independent probability of A and B occurring is the probability of A times the probability of B. If it's a dependent event, the probability of A and B occurring, the probability A times the probability of B given that A has occurred. And so dependent events will depend on something happening on the first, and it will maybe change the probability. But again, it's still going to be multiplication when you work out the total details. Let's look at an example. Let's say we're wanting to know what's the probability of getting an ace out of 52 cards. Well, there are 4 aces in that first. Now, you notice I've got this listed twice, and the reason I've done that is what happens if you replace that card. If you draw an ace, there's 4 chances out of 52 of getting it. If you replace that card, there's still 4 other chances out of 52 of getting an ace on the second card. And you would multiply those together. That's 1/13 times 1/13, which altogether comes out to be, well, sorry about that. 1/13 times 1/13 is 1 over 169. So there's 1 chance out of 169, because we just multiplied the 2 events together, of getting 2 aces. Now, that was with a thing called replacement, because we did replace it. Now, if it's without replacement, just think about this just a little bit. The first card, still 4 out of 52, isn't it? 4 out of 52. But now you did not replace it, so there are only 3 aces left, and there are only 51 cards left. So your probability here is 1/13 times 1/17, and whatever that comes out. But it is a less probability of, it changes that probability here from 1 over 169. But that's So you need to be careful of replacement and without replacement. Now things can get more complicated, and there are formulas that will help you on this. For example, and we won't talk about it as far as formulas, but if we talked about what's the probability of drawing an ace on the first one and maybe a spade on the second one, you'd have to remember that probability of the first being an ace, she also had an ace of spades in there, that it was possible. So it can get a little more complicated. But for our purposes here on basic probability, this is really all we would need to know. But those are some key components about probability. Again, probability, the event occurring, what's the probability of an event occurring, is going to be either greater than or equal to 0, but less than or equal to 1. And the total probability, obviously, is going to be 1. So, as we look at statistics and we look at probability, that's just some basic components. And so, until next time, happy SAS to you until we meet again.